Hello, my name is Maly, and this is my demonstration project for MAE 535 Electromechanical Systems. Faraday's law states that as a coil is moved through a magnetic field, a voltage is induced in that coil that will try to maintain the flux linking the coil. This can be shown in two ways. The first is to have a time-invariant magnetic field induce an electric current in a moving conductor. Think of a permanent magnet motor. Or you can have a time-varying magnetic field induce an electric current in a stationary conductor, such as a permanent magnet generator. For this project, I will make a permanent magnet generator to show how Faraday's law can be used. Here's the setup of the experiment. The system is a two-pole system where the magnetic poles are oriented 90 degrees from the coils. The magnetic field will go from the north pole to the south and then back around. This magnetic field will cross the coil of wires. The magnet will then be spun 180 degrees and the process is repeated. The switching of the magnetic poles will induce a voltage in the magnet wire. To calculate the voltage that is expected, the equation for Faraday's law from class was used. In this case, the voltage can be reduced to N times V times A. The area and the magnetic flux were found from the manufacturer's website. For this experiment, 4 neodymium magnets and 30-gauge magnet wire were used. The magnetic flux was found to be 0.88 teslas, and there were 270 turns of magnet wire. The area was found to be 7.85 times 10 to the negative fifth meters squared, and the predicted induced voltage is 0.0186 volts, or 18.6 millivolts.
Okay, so this is the setup I have for my experiment. I have my positive and negative leads hooked up here to my multimeter. I am using 30-gauge magnet wire, and I have 270 coils. I have 4 neodymium permanent magnets on a shaft inside of the coils, and then that will be hooked up to my drill that will be spinning the shaft.
As can be seen, the voltage was switching from a negative value to a positive value. This is because the actual current is alternating. Because of the scale of the voltage, the AC measurements on my multimeter were not able to be used. In order to get the voltage that was being induced, the maximum value that was seen on the DC voltage was recorded as 0.0159 volts, or 15.9 millivolts. The percent error between the calculated value and the measured value was found to be 14.75%. There are many reasons for the error. First off, the windings were not perfectly done because I wound them by hand. Second, the hole that the shaft was going through was not perfectly in the center of the PVC pipe. This caused one side of the magnets to be closer to the wall than the other side. Also, the multimeter sampling rate was too low to run the drill at full speed. For this reason, the speed had to be manually controlled, and it was not easy to keep it constant. Here are the references that I used for the values. Also, I would like to give a special thanks to John Maly and Stephen Strom for helping me during the demonstration. This concludes my presentation. Thank you.